Hello and welcome. Welcome to the second session of this series of webinars depicting different wavelengths. After the first one, which was about VNIR, here you are now present for the second one, which is about NIR spectroscopy. NIR, which is between 900 and 1700 nanometers in our Specim jargon. So, you know me, I am Mathieu Marmion, lead application specialist at Specim. I will be really happy to host you here during this session. This is the agenda. So, first we will go through a Specim company presentation to tell you again who we are. Then after that, we will explain about NIR hyperspectral imaging and hyperspectral imaging in general. Then we will go through some applications, which ones are really dedicated to the NIR spectral range. Then we will show you the products that we are having, exactly covering this spectral range. Finally, I will go through some requirements, for instance, of illumination, and then I will be really happy to answer all of your questions. First, about Specim, who we are. Specim has been founded in 1995 in Oulu, the headquarters in northern Finland. And since that time, we have delivered more than 10,000 cameras and spectrographs. Since 2020, we are now part of Konica Minolta, and we have been growing worldwide. We have nowadays offices in the United States, Germany, Spain, and also China. All in all, we are globally present, and if you are located in a country where we are not locally ourselves present, we can have a local distributor as well. Now, let's speak about NIR hyperspectral imaging. As you know, hyperspectral imaging is a combination of imaging and also spectroscopy. So basically, there is a spectral information which can depict and retrieve some information about what you are looking at, for example, properties like fat content or things like this, but also like which material is somewhere, and also spatial information which depict more like the distribution of something. And hyperspectral imaging is a combination of both of them. Here you can see on this slide how the wavelengths are defined. The electromagnetic spectrum is defined over the different wavelengths. Also, emphasizing the products that we are having at Specim. As you remember, about a month ago, we were dealing with a visible NIR spectroscopy between 400 and 1000 nanometers. Today, we will focus with the NIR spectroscopy. Many people call it sphere, but we still, at Specim, call it NIR, between 900 and 1700 nanometers. And here you can see the three products, but I will come back to it a little bit later. Hyperspectral imaging is actually obtained with a hyperspectral camera. You can get what we call hyperspectral cube. All our cameras are line scan device, so you image sample over a line, and each pixel of the line providing independent spectral information. As you can see, you need to have illumination from both sides. It's better. And what the hyperspectral camera does, it basically measures the reflected light compared to the incoming one. And then for each pixel like this, you can extract a spectral signature. You can see on the left-hand side of the image, hyperspectral cube or hyperspectral images acquired with first a RGB camera, then an FX10, and then an FX17. You can see the spectra that you can obtain. So for example, here in orange, you can see the spectrum of almond, whereas in purple, this is the spectrum of the shell. And then based on that, you can make a model which is acting like a fingerprint. Each spectral signature is like a fingerprint for different type of material. And then you can make a classification. And as you can see here with FX17, quite often you can get better results than with RGB camera or with FX10, but it depends on the application. Why is that? It's because actually with the NIR camera, you don't see the color anymore. It was a fact with the FX10, but then with the NIR camera, you go deeper into the chemical analysis of your samples. You know, in your material, you have different type of molecules and different type of atoms and so on. And then when you send an electromagnetic waves, which is basically light, depending on the molecule, the light will be absorbed, transmitted, or reflected. And this is actually what we measure. Depending on how the light is reflected, Then we can see different type of component, different type of molecule, and you can see that for those one, as an example, those between 900 and 1700 nanometers, you have quite a lot of information, how the light is absorbed. So for example, protein, water, lipids, carbohydrate, and different type of molecule have good absorption band within the spectral range between 900 and 1700 nanometers. And this is its properties which is used to get actually spectra. Different application, those which benefits about NIR hyperspectral imaging. You recognize this graph, this pattern, we had the same last time, but this time with different type of application. Waste and recycling is an important one. Food also, to detect different type of contaminant or to grade the food, depending on the property. Remote sensing is another one. Moisture measurement, we will go more into details with that one. Art and culture heritage, it was already present for the FX10 or the IQ because of the visible spectral range, but also it is important for the NIR spectral range. Film thickness, pharmaceutics, and maybe your application, which could be a new one. First one about plastic recycling. Here we measured different type of samples with different type of material. PE, ABS, PVC, and some other one, those which are the most common one. Then we measured them with FX10, FX17, SVIR, and FX50, and with the FX17, you can already separate a big part of them. Not all, but most of them. Maybe the PC was a bit more tricky, but anyway, if you consider what you can sort, looking at the price of the camera, this is a quite good trade-off. So this camera is used widely for plastic recycling. Here is an example. It was a company, Prodecologia, which is located in Ukraine, and they are using FX17 combined with the Specim one to sort different type of polymers. And they managed to reach an accuracy of a purity of 98%. They were sorting, if I recall well, PE and PP. Flakes like this. So they were using our technology and it was working pretty nicely. Then the next application, it is textile recycling. By 2025, in European Union, we will have to recycle all our fabric. And that makes sense. Imagine this shirt. The fabric could be used again. Either it is cotton, polyester, whatever, it could be used again. And it has been researched that actually a cloth is thrown away only after 7 use, which is a pity. So it needs to be recycled also because the material to make clothes is actually pretty expensive for the environment, for example, cotton, and also it could be used as a polymer. Anyway, we measure different type of fabrics with the FX17 and we have seen that different spectral signatures were related to each of them. So again, here FX17 is suitable to sort different type of fabrics. Another type of application is for the food grading, but also for foreign object detection. Here you can see of this piece of meat with actually a RGB camera, you will not be able to separate easily what is a contaminant made of plastic, wood, or for example, the fat and the meat, whereas with the FX17, also a little bit with the FX10, but more accurately with the FX17, you can spot those one. Also, you can detect where the fat is located compared to the protein of the meat because the spectral signature is not exactly the same one. Another application where FX17 is performing really, really well. Here, again, another example for food grading about the meat. This time we can see on the image some cartilage. This camera for covering the NIR spectral range are very suitable to spot them out. And it was one of our customers which has been able, like in DO, like in Spectral, to be able to sort like this, those contaminants from the meat. Another application which is very relevant for this spectral range, it is the heat-sealed inspection for the packaging. We all go to the shop and we buy some meat or some ready-made food, and you have a container which is covered with a thin plastic which is sealed all around. But if you would have a contaminant in the place of the sealing, that will trigger to have a leaking, and you don't want to have that because it means that the food inside will get damaged. So with the FX17, but also potentially with the GX17, you have the possibility to detect if you have some contaminant in the place of the sealing, and then you can actually improve the detection of this kind of issue. And here it was actually successful case from our integrator Minebea, who used our FX17 combined with X-ray to obtain this kind of image. Another type of application for food grading, it was the monitoring of contaminant like thin residual of plastic on block of cheese as well as mold. And here is pretty interesting because you can see that this time the FX17 is mounted on a robotic arm with the illumination. And this was moving all around the cheese like this to detect where you had those defects. So another type of application where, yes, the FX17 could be used. It was a successful integration for the company Alpna. In these stories here, in this study, there is no customer. It's something that I have done myself. So we actually bought some minced meat with different level of moisture and also different level of fat. We sent those samples to a third-party laboratory to estimate exactly what was the moisture and the fat content of each of the samples of the minced meat. Then I measure those with the FX17 and I build a regression to see if we can quantify accurately those two features. And here you can see that this camera, this spectral range again, is very suitable to quantify, to measure accurately the moisture on one hand and also the fat of the minced meat. Here you can see the regression graph, what is estimated versus what is predicted, and it's matching really well. The red dots are the ones used for training and the green ones are used for validation. Here we go back to we go to Netherlands, to the University of Wageningen, where a hyperspectral imaging platform has been built based on our FX10 and FX17 for like different type of samples and food monitoring. Here, this is an integration of this both camera to monitor the freshness and also the maturity, for example, of the fruit, different kind of defect, but all type of sample could be measured as well. Moisture content is actually a very important concept. It's not here an application which is going to make a revolution of everything. So here it was like a cotton pad, really wet and drying over the time. And this was measured with the FX17 and it was measured every 4 minutes. So here you could see the drying. This is the same cotton from the top left, then it goes like this down to the bottom right, and each sample, each measurement is taken every 4 minutes. The point here is not really to measure to measure the moisture of a cotton pad as an application as such, but it's to show that the FX17 or the GX17 are suitable to measure the moisture of something. The moisture of something is very important to monitor as well, either when you want to have a process, when you want to monitor your industrial process where moisture plays an important role, or it could be when you want to burn some fuel. So for example, pieces of wood, like if it's too dry, it burns too quickly. If it's too wet, it doesn't burn. So it just needs to be moisture exactly at the right level. So just to show that actually this spectral range is suitable to measure the moisture. And you can see here with different spectral plot that depending on the moisture, the water absorbs and is more present on the spectra. So for example, water absorbs significantly the light at 1420 or 1430 nanometers. And when the sample is really wet, you can see that the spectrum, the water absorbs really strongly the wavelengths around this spectral band. But then when it gets drier, you see that the water absorption raises, and then you start not to see that much anymore. But anyway, from that, you can make a quantitative analysis, a regression, and this is what has been done here with this study, with this example. Another type of application where the NIR spectral range is very suitable, it is pharmaceutics. Here we had a successful integration of our FX17 to monitor different type of tablets through the blister to monitor paracetamol or aspirin or ibuprofen or whatever different type of tablets to see if you would have contaminant or if different type of tablets they would have the right recipe in terms of ingredient, different type of quantities. Again, here successful integration for this type of application. Another one, we spoke already about it last time with the FX10, but it could be used as well with the FX17, is to measure the thickness of thin film. In the traditional way, there is a point spectrometer which is moving from the left to the right and so on, and then the film is moving, and then you can measure along a zigzag pattern the thickness of the film, but it's only along a zigzag pattern. With the hyperspectral camera, you can measure it with a line every time. It means that you can measure over a much wider area than with a point spectrometer. So here it's a clear benefit of hyperspectral imaging compared to the current solution. And here, with the FX17, it's possible to measure film with a thickness between 4 and 90 micrometers. Okay, that was it for the application. Now we are going to speak about the device that we are having covering this spectral range. First, we have the FX17, which is here between 900 and 1700 nanometers. And we also have this one, the GX17, covering exactly the same spectral range. Both, they are complementary to each other. I will not say that one is better than the other one, it's just that they have their pros and their cons. For instance, the FX17 is having more pixels, but the GX17 is also faster. So if you want to go really into details about what are the differences, I recommend you to download actually the datasheets that you can find on our website, www.specim.com. Also, during the Q&A session, I will be really happy to answer questions about those two devices. Those devices could be used as well with some accessories. So if you want to use them in a laboratory, you can put them on our lab scanners. We have two versions, the one 40 by 20 centimeters for samples as large as 40 by 20 centimeters. And we also have the 100 by 50 for samples as large as, I let you guess, between 100 and 50 centimeters. Finally, we also have the rotary scanner if you want to use those in the field or if you want to measure a scene. Basically, the camera is looking sideways, and by rotating like this, you can measure like this your image. Also, we have the NIR version of our AFX camera for this. Basically, you have an FX17, which is mounted in there with a GNSS IMU unit embedded with it, and then you have the possibility to use our AFX for remote sensing application. Here you can see it is also mounted on a UAV, so we have this wavelengths available for airborne for remote sensing application. Software-wise, we have Specim Insight, which is our processing software. Here you can analyze the data to extract information from the spectra. And we also have the LUMO software, those one which include more the SDK, so you can already build your own software. You can interact with the camera by yourself using the SDK. This is the same, by the way, for all Specim cameras, so GX17, FX17, but also FX10, FX50, all of them. It is the same SDK, but you also have LUMO scanner, LUMO recorder, which are the software suitable to acquire data with the scanner. Finally, we have also Specim One, which is our spectral imaging platform, especially for the industry. Here, this is a platform which includes the cube, the processing platform basically, which is a GPU. We have Insight, which is part of the package, and the camera, FX, and also GX17. So basically, it works that way. It can be combined together. You have the camera connected to the cube. With the cube, you can acquire the data. Then, once you have acquired the data, you can build a model with Insight. Once you are happy with your model, you can then convert it into an application that you load into the cube again, as the cube will be able to process into real-time data that you are then getting from the camera with the models that you have made previously. And then the output is either in GigaVision format, and we have our own UDP protocol. Then you can use it in a sorting machine, as you can see here on the example. Be aware that the output, because it's GigaVision protocol, following this protocol, it's compatible with many players in the field, in the industry, for example, LabVIEW, Becom, Halcon, but there are also some other ones. Another aspect which is crucial for hyperspectral imaging, it is the illumination. And we spoke already a little bit about it like last time for the NIR spectral range. Here you can use almost the same type of illumination, halogens, which is the one basically which is preferred for this spectral range because it is bright. But it has an issue, it is a lifetime and also the heat. So if you are concerned about that, be aware that it exists as well, some LEDs available for the spectral range, and we tested some and they are really good. We can also sell some as a third-party product, but we have some available. Laser, super continuum laser is also an option which is available. We have tested one between 400 and 2350 nanometers, so very fitting as well for the NIR spectral range. And of course, at the end, there is a sunlight, which is one source which could be used for the spectral range. Just be aware of the atmospheric band, which can absorb quite strongly actually the light over the spectral range. Here, I would like to speak about some of our customers, because without our customer, we will not be successful. So I would like to thank, of course, all our partners and our OEM, which are using really our device in a successful way. And here you can see actually Emilio de la Red, working for Indeo. And I'm just reading, integrating HSI to machine vision equipment, we automate the work of 2-3% per shift, resulting in up to 100K euros saving per year. We also reduce the risk of quality failure, which can save 100 to 500 kilo euros of penalty. So here, they are using our camera for the application. I'm really happy to see that Emilio is happy. It's a success of both Specim and also their company. Another one, it is like PICVIXA. They are using in their plastic sorter FX17. Our plastic sorter EcoPack, equipped with Specim FX17, can sort up to 6 tons of plastic packaging per hour. This was previously done by 6 workers. So again, here, successful implementation of FX17 in a plastic recycling sorter. And then the one of Prodecologia, using our Specim one with FX17. The implementation of the NIR separator with the Specim one only took 6 months, which is pretty fast, which was a vast improvement compared to other systems that were stuck in development for several years and never reached full completion. So again, here, Specim one has been able to make a fast implementation for a quick return of investment. So again, here, the combination of everything to make successful sorters. If you want to contact us, if you want to have a demo, if you want to have like a sample measurements, if you need to have a quote, if you need to know some pricing, please contact us. You can go to our website, www.specim.com, but you can also send an email at info@specim.com, and then we will be really happy to answer to you. Remember, this is an NIR webinar. In about a month, in the 16th of November, there will be the severe shortwave infrared webinar. So we'll be really happy to see you for the next one as well. Now we are ready to answer your question. Anyway, so now I'm really happy to answer your questions. So the first one was about are the camera able to focus an object located at 20 centimeters from the camera? I have to say it depends on the lens. So we have some front objective which are able to focus even down to 15 centimeters, some other one down to 30 centimeters. So it really depends on the front objective you are using. Having said that, we have some lens with a C-mount option on it, as then it's possible to mount an extension tube. So when you have the extension tube like this, you can also get closer to the sample, but it is at the expense of the light throughput. So basically the F number is increasing. What type of communication with PLC do you offer? So I think this question relates to the Specim one. With the Specim one, the output, it is our own UDP protocol or the GigaVision protocol. And there are many companies which include, which provide PLC, and they have how do you call that, computing environment system. And those ones accept very easily GigaVision protocol. So we have the GigaVision protocol. So we have some customer using, for instance, Halcon or Beckhoff, and they have been able like this to trigger some PLCs. Nice and clear presentation. Thank you. I am a novice to this subject. To question, are these snapshot camera? No, they are line scan device. And for each pixel of the line, you get independent spectral information. How do we visualize image in specific wavelengths if I want to build an AI model, says for segmentation. Well, typically you don't want to really see the image at a single wavelength because then it's not really using the power of hyperspectral imaging. If you want to see an image at a single wavelength, just buy a camera sensitive to that wavelength, so you put a filter in front of it and that's it. But if you want to do that, you can still have your cube. So basically for each pixel, you don't get only like 3 band like RGB image, but you will get more than 200, for in our case, 224. And then you just select these bands that you can see what you have in there. But it's better that you are looking for each pixel, the spectrum, so that you can actually get the spectral information. For example, do you support Ethernet IP for Rockwell? To be honest, I don't know what is Rockwell, but we have as an output for the cube, we have Ethernet connection. We have GigaVision protocol. And for the camera, we have, at least for the FX17, we have the Gigi version as well. For the GX17, we have only camera link. Do you provide cameras for clients in hazard management, fire and rescue service, or other defense industry? Yes, we provide camera in every application. Military is one. And for example, we had customer using, for example, to detect different type of camouflage, or to detect different type of ignition gas. But I have to say this spectral range is maybe not the best one for military application. Sphere between 1000 and 2500 nanometers is better, as well as the thermal range like MWIR and long wave infrared. So here these are the range which is better fitted for this type of application. I start to have many questions. I have to move a bit. Which spectrum is suitable for paint thickness measurements? That depends on the thickness. Because the longer you go with the wavelengths, the more you have a penetration depth. So depending on the thickness and depending on the paint, you have to go for longer wavelengths. So for example, I have been investigating, like metal part covered with some painting. And for some application, FX17 was not enough, but you have to move up to FX50, which is in longer wavelengths, so that you can see actually a bit deeper. So it depends on the thickness. The first question, it was not 200 millimeters, but it was 200 meters. Well, whatever length, you just focus them to infinity, and then you will see at 200 meters. This is not a problem. Then the thing is that you would just have like a high, in metric, you will have a field of view which is pretty high. Then you need to have a lens which have a narrow field of view if you want to see something accurate, but it doesn't matter. The lens, you just focus it to infinity, and then 200 meters is not a problem. Can you use the NIR camera with transmission illumination? Yes, no problem. You can do that. So typically, you can have the sample, the illumination, and the camera at the top. The light is passing through, and then you can visualize this transmission. If you have a sample which is super wet, then you might not see any light because typically, like water absorbs everything in the NIR spectral range. But still, you can try. You can operate. Given that there is 2 spectral range for 2 different cameras, FX10 and FX17, how will I know which one to use? Assuming I'm not sure what kind of contaminant in the samples that I wanted to sort out. That is a recommended step to select the best range. Well, first of all, you need, maybe if you can have a trial, first you have a trial. But the good thing with the contaminant and what you want to detect, for example, is if you're in the food industry, you have to think what the contaminant can be. If you think, for example, you are dealing with minced meat. In minced meat, you have fat and you have water. In your contaminant, you may not have fat or water. So you can focus at some wavelengths where you have the fat and the water, or the sugar, depending what it is. And then you can think that if I have a contaminant, obviously it will not have those components. So then you can think that way. But of course, the easiest is like when you can test your contaminant, first you see the spectral response with FX10, FX17, and also your product, and then you choose the right camera. But you could think also, as I say, the other way. What is good, what might not be good, and then, yeah. In the example of the mold in cheese, where you had a robotic arm, the arm had a camera array of 8-10 camera. Is this because the target mold was too small or you needed more resolution? No, you are mixing. It was not the camera, it was illumination. It was an array of illumination. Those were halogens, and there was only 1 camera on the arm. So basically, the camera was looking between 8 bulbs. There was 4 on each side, if I recall well.
And this is what you were seeing, but there was not a camera array. Is it possible to couple your device to a microscope? Yes, it is possible. I have seen people doing that. So basically, you don't use a typical lens, the one we provide with, but you can remove it and put a C-mount adapter. Of course, you need to have a microscope with a C-mount adapters, and you can put the camera on it. Then there are a few things to take into account. First of all, the transmission of the microscope. Typically, the optics is only between 400 and 700 nanometers, which is a visible spectral range. You have to consider as well the illumination, because it needs to be a hyperspectral illumination, meaning like covering the full spectral range continuously. And then you need to have a motor so that actually you can scan your samples. But if you have all those conditions which are matching, then it's okay. Be aware that with the FX17, we have what we call a macro lens, and then we can FX17 also GX17, and then with that lens you can have a pixel size which is about 20 micron. Is it possible to mount, for example, that's towards stereo microscope? That's the same question somehow. Is it possible to detect people hairs using NIR camera in food domain area? It depends on the spatial resolution. Typically, if you have a narrow field of view, then you will have small pixels. If you have small pixels, then you can detect small objects. But if you have bigger objects, then it's more difficult, or you need to put several cameras next to each other. If you think about hairs detection, I'm a bit cautious with those because typically it's about 40 micrometers. And it is so with the spatial resolution you can get when you want to measure an object which is maybe 10 centimeters large or something like this. So it might be better here to use like high RGB resolution camera. What is the approximate number of image line data that is required to train a classification model for the example you showed about the meat? Here I had 10 samples of meat, and I used 8 to build the model. I did not use more than that. But if you want to be more accurate, I would say you need to have maybe 20, 30, and then you can try. You can adjust your model, you can make it more accurate. But in the example I was showing, I had 10 samples together, 2 for validation, 8 for model training. Okay, what is the approximate weight range for cameras that works in mid-IR? Are these cameras active type? No, all our cameras are passive. So basically they do not emit like a laser or something, or like with a lidar or something like this. No, they are just passive. So basically you have the light and then they measure what is a reflected light. For the mid-IR, the weight, I think it's 7 kilos, the weight of our FX50. Is there an example application of UAV with FX17? Well, for soil analysis. For soil analysis, typically AFX17 could be used, or if you want to see if the soil has been disturbed, which is more like a military application. AFX17 could be used as well for precision agriculture, but typically for precision agriculture, it's more like an AFX10 application, but they could work next to each other. Which model can be recommended for the organic and the inorganic pigment IDs, Specim, Specim IQ, or FX17? Here, if you want to map pigment, we had people who had been using the VNIR, but also the NIR spectral range, because typically pigments, they were made, as you say, of organic and inorganics, meaning like could be like minerals, it could be pieces of wood and things like this. And typically what I have seen is like it's better to use FX17 because the FX10 or the IQ, it's more about the visible part. So if you want to inspect the chemical structure of your pigment, if you want to identify them, you have with the VNIR camera only the spectrum between 700 and 1000 nanometers. If you use an FX17, then you have a spectral range which is wider and which is more chemically oriented. So I would say FX17 might be better for that. But here again, you may contact people in the art business, in the museum, which are making research with our instrument, and then they can give you the best advice. Is it possible to detect leaf disease from plantation based on spot? Yes, with our camera, you can really detect if you have like some plant which are sick. Of course, it depends on the height where you are flying or where you are having a rover or something like this. If you have a high spatial resolution, you may detect small spots on the leaves. If you have a higher resolution, I mean, bigger pixel, then you will have to have more like you may not detect if a leaf only is sick, but if the full bush is sick. But again, yes, we have people using our AFX10 and AFX17 for pest detection, for example, in the fields. To your knowledge, has somebody used NIR HSI camera for microplastic detection? Yes, many of them. We have actually quite a lot of people approaching us for this type of application. So basically, you can use our FX17, GX17, or even the Sphere camera, which is between 1,000 and 2,500 nanometers with a macro lens. Remember, with our macro lens, you have a pixel size which is about 20 micron, and already from here you can really detect and identify different type of microplastics. So yes, we have people using our camera for that. How is the AFX17 controlled when airborne? Either software for ground control of the camera. So basically, we have a flight management system. So you have the camera and you can program that when you are at certain position, the acquisition will start. When you are at another position, the camera will stop. And then you can make like this a pattern to record several lines. It's good to align this flight management system with the one of your drones. So then you can make them match somehow, and then automatically those data will be acquired. What about underwater application for seabed inspection? We had actually people who had been using the camera for that. So here I would say you have two approaches. The first one is that you could be with an AFX10 from a remote platform like a UAV, and then you can see the bottom of the sea, but remember that you cannot see more than about 5-8 meters. This is what our customers have done. Then they can map along the coastline. If you want to go to deeper area, like at the bottom of the sea, you need to have what we call a submarine, like or rover somehow, and you need to have artificial light. And again, it's an application for FX10 or AFX10, someone will say more like FX10, and then you can map like this the bottom. But here, the most difficult part is to take into account the illumination and also the casing for the camera and everything. But we had people actually in Norway who have been using our camera like this in a casing in the sea. Do you have any client detecting absorption due to the presence of gas in the air? Yes, we have some people, especially for military application, who has been using our camera to detect the presence of different type of gas, for example, CO, CO2, ignition gas when you have a rocket or things like this. Because actually some of the cameras, depending on the spectral range, but some of the camera could be very sensitive to the presence or the absence of some of the gas. What is important to take into account when you want to measure gas, it is the temperature of the gas in relation to the background. So if you have a hot background, it's nice to have a cold gas. If you have a cold background, it's better to have a warm gas. You need to have a contrast. But then, yes, it's possible to do that. We have customers who have been using our camera for that. Be aware that with the line scan device, you need to have a scanner, like the rotary scanner I was mentioning during the presentation, and then it's all good. Is the flight control software for AFX17 specific to DJI, or does it support open source? No, it is not specific to any other one like DJI, but if you make a flight map or flight planning with DJI, you can make the same planning with our flight management system, and then when the DJI drone will fly somewhere, when it will be at a certain position, you have the same position in our flight management system, then it will trigger and stop and so on.
Back on the live and ready for your questions. Actually, I have one question from the first session of today that I'd like to ask Kevin's opinion about it. Is it possible to detect people's hair using your NIR camera in food domain area? What is your take on that?
Well, you need really high resolution. So the FX17, if you either paired cameras together, you might be able to get that resolution. But human hair is very small, so if there's enough of it, we'd probably be able to see it. But that might be a little bit difficult with the resolution of the FX17.
Okay, Then we have another question. Is the AFX17 sensor model be used for mineral exploration?
Some minerals it can. Yep, there'll be some absorption features in the in that near infrared area from 900 to 1700 nanometers. The SWIR would be a little bit better. You get some more minerals out past 1700, but you can pick some minerals with the AFX17.
Okay. The next one is, what is the primary concern for the heat produced by halogen illumination sources? Just thermal effects for certain samples, for example, melting, etc., or is there a possibility it will affect the spectrum's quality?
No, it's more the heat, I guess, coming down. But typically the sample is moving so quickly underneath the halogens that the heat isn't really that much of an issue. But you don't want the conveyor belt in an industrial situation to stop underneath the halogens for an extended period of time. But yeah.
Okay, and then there's a question that I can answer. Is it possible to download a record of this webinar? Yes, you will receive the link for the recording automatically in a couple of days. In terms of dollars, how does an NIR system compare to visible or SWIR? Are they comparable?
Yes, to my knowledge, the FX17 is a little bit less expensive than the SWIR and a little bit more expensive than the FX10. But that's just because it's seeing a different region. And it's using an in-gas detector, which is a little more expensive than the FX10's detector.
Okay, what are the classification models used in the examples shown today?
Mainly PLSDA, as well as PLS and the quantification algorithm.
Any more questions? We are here for you guys. So shoot ahead. We have at least a few minutes to spare for this.
Maybe Matthew's presentation was just so good.
It might be, yeah. One that was asked earlier today, is it possible to mount these devices on a microscope?
Yes, in fact, we have a fiber optic example for the FX17 where you can actually have fiber optic cables going in there. But yeah, you could have just one fiber optic cable in theory going to a microscope.
Okay. Please, are there some facilities for education and research institutions from Specim?
Well, we have our knowledge base. If you're a customer already, you can go to the Specim community where there's a lot of information and some tutorials as well. We have some other tutorials on YouTube.
Yes, as well on our website on the technical section. Are typical lens class optics adequate for this spectral range?
They typically are specialized lenses, not visible, for instance, but any lens that works with the shortwave infrared will work with the FX17 in most cases. But the coatings are slightly different for visible versus the near infrared and SWIR.
Okay, then's the next one. Is it possible to use the portable drone mounted for in-field measure of pharmaceuticals?
So the AFX camera, if I'm understanding this correctly, the airborne version to use for pharmaceuticals, is that correct?
I guess so.
Okay. Yeah, the camera is typically, for the AFX is typically focused to infinity, just because it's flying up in the air. The same camera, however, that's in the AFX17 is also the just the FX17. So you could use one for both, but the resolution or the focusability of the AFX may be a little bit limited.
Could you share more information about Specim Insight? What info is included in Insight?
Okay, so the Insight is our analysis software. There are actually a few webinars on it as well that I know Matthew's done that are really good and very insightful. But yeah, the software is mainly used for sorting and analysis and classifications.
Yeah. And there's a question, are optics for resolution smaller than 50 micron available?
That I'd have to check on. I'm not sure on with the FX17, but it's possible. I'll have to look at that.
FX17, can it be used to find the fertilizer intake in plants or leaves?
That's typically, I think, going to be more in the visible near infrared, but you'll actually be able to identify some of those materials with the FX17. The two together would be a really good combo to use. But yeah, you can see some of those substances in the soils with the 17.
I'm trying to check if there's anything that I missed. Did I ask you already this? Does the FX17 sensor perform a topographic survey? If not, what needs to be implemented?
You haven't asked that one yet. That would probably be more of a LiDAR application for topography, but you could scan with the AFX, for instance. You could use a topographic or a DEM to look at each pixel on the ground and elevation, but it doesn't actually collect any topography. It's not a stereo pair or a LiDAR in that sense.
Okay. The next one, for drone use, what is the recommended flight height with respect to the topography to collect the optimal spectral information?
It depends on what you want for your ground GSD or measure your ground pixel size. Typically, we're flying not that much, certainly lower than a fixed wing aircraft and certainly lower than satellites. But it really depends. It's dependent on your needed GSD of your project. But we can advise on those GSDs based on your application.
And then how FX17 is used in agriculture industries?
Typically the visible near infrared is used a little bit more in ag, but you can also look at water stress and things like that in the near infrared, which will be very helpful for determining plants' ability to photosynthesize and intake water as well. General health.
Yeah.
As well as soil health.
And then what kind of effect will appear on resolution if it's used in microscope?
Not quite sure on that one. I'd have to check a little bit further on that, but yeah, in theory, the fiber optic would be more of a point spectrum, but you could also use it as an imaging system.
Any more questions? I'm scrolling through the list. Did I miss anything? These are excellent questions, by the way.
Yeah, very good.
Then the question about the illumination with halogen lights. What are typical wattages used in your system, for example, for FX10 and FX17?
Depends on which system we're using. Sometimes we use what's called the Sisu Kima, as well as the lab scanner, the 400 or the 40 by 20, as well as the 100 by 50. I think the wattages are slightly similar, but we could send you more detailed information on what those power consumption needs are.
And then there's a question, what is the typical response of the sensor to increasing temperature?
Well, so the camera itself internally is cooled, but yeah, if you're looking at something that's getting hot, you can actually do some measurements on basically the subject's heat and how it's emitting heat. Yeah.
Okay, then there's a comment that thanks for showing such a variety of industrial application. Thank you. It's our pleasure. It's one of the reasons why we are doing these webinars. Any more questions coming? Let's see. Then from the previous session, I know that this wasn't answered by Matthew in the morning. For airborne application with AFX10 and AFX17, what is the software used and how the image stitching mosaicing is performed?
Okay, so typically we sell our software CaliGeo Pro, which you can use to do your bore sighting and do your image post processing of your imagery. Typically, that also CaliGeo Pro runs in ENVI, so you can also do your stitching and your mosaicing in ENVI. There's a variety of software also that you can use for stitching and things like that. We have actually a tech note on third-party software you can use for that, so we could send that along.
Yeah, and I'd like to mention that if you want more information, please visit our website, specim.com. There's plenty of information available. Then there's a question, do you offer training on the use of the sensors and softwares, or do they come at additional cost?
Depends on the project, but typically we provide certainly some documentation ahead of time and manuals as well. We can come on site as needed. Typically that is purchased, but we can do that on a case-by-case basis.
Can you comment on the lifetime of the camera and the lens system in industrial environment?
So it depends. I mean, you can prolong the life of the camera by using an enclosure. There's a few vendors that we recommend that can house the camera itself. You can also use the camera outside of that environment. It's a little bit less, it's more susceptible to like water damage and things like that. You wouldn't want to get the camera soaking wet, for instance. The typical lifespan of in-gas detectors is about 7 to 10 years, so they can last a long time. And the optics, I mean, as long as it's kept fairly protected and in decent, in a good environment, especially if it's enclosed, will last quite a long time as well, just as long as the detector, if not longer.
Then we have a multi-part question. Is NIR hyperspectral camera suitable for land cover mapping and classification using UAV? Do you have some experience with it, or visible plus NIR? Is it better?
Depends on your application, I guess, on the second part of that. Yes, we do. The AFX camera will be able to do airborne applications. The second part, the visible near infrared is very good for some types of applications in plants and things like that. And the AFX 17 side, you could be detecting plastics, things like that, or other targets in soil health. So it really depends on the application.
And then, does the sensor degrade over time?
Yes, it is measuring radiation, so it will degrade over time. As I mentioned a little bit earlier, the AFX 17, the FX 17 and AFX 17 are in-gas sensors, and they will last about 7 to 10 years before they start to have what are called bad pixels. And that's just the detector kind of wearing over time. You can prolong that, and a lot of our software actually can do some of that, the analysis to basically take out those bad pixels.
Then there's a question, are the handheld sensors available for field work in agriculture? Seems like
So the-
IQ to me.
Yeah. So the IQ is a visible near infrared. So it's not the near infrared. It's not the same as the FX17. The FX17. The IQ is portable though in the visible near infrared and is good for that type of application.
What are the limitations with respect to the sensor's power supply, climate, temperature, altitude, and autonomy?
That sounds like the AFX. We can certainly send the specs on the temperatures and things like that of the AFX cameras, the specs of the temperature gradients and the differences. But they're pretty ruggedized. They're in a carbon fiber shell, so they're fairly ruggedized, and we can send the full specs on their temperature thresholds.
Then there's a comment from Petri Nygren. Hi, Petri. VNIR AFX10 would be the best choice for classic land cover mapping. You're true. You're the expert, you know.
Yes.
I think we have time 2 more questions. Are there anyone willing to shoot more? If you want our sales team or marketing team or application team contact you, please write yes on the chat. If there's something that you want to discuss in more private manner, we will contact you. Do you, Kevin, have any expertise with underwater measurements?
Not me personally. No, I a little bit from an airborne standpoint of trying to see through water a little bit within the VNIR, but not actually submersible. So no, that sounds like a cool application though. Interesting.
Yeah. I think we had a customer in Norway who was measuring lysis on salmon underwater.
Okay.
Then there's a question, how many bands does the FX have?
So the FX17 has 224 spectral bands.
Yes. All right. It's getting late here in Finland. So, and questions are running low, so I think we can start to wrap this up. Thank you for participating, and thank you for your excellent questions. And thank you, Kevin, despite the flu, for taking part in this. But anyway,
thank you.
We will see you in a month when we have the next webinar on the sphere. So until then, take care. Bye.
See you then. Bye.
Yep.